All right, so now we're doing a concentration mass problem. Our concentration mass problem is going to be a stoichiometry type problem where there's a reaction. If anyone does need a break now, though, they can start the break and just come back. Like if you need to, go ahead and do that. But I'm just going to continue here with this. We'll start a break at 2 o'clock officially. Okay? So we'll just finish this one up, and then about 2 o'clock we'll start a break. So no worries. Not all recordings can be perfect all the time. I try. So calculate the mass of magnesium chloride needed to react with 60 mils of 0.30 moles per liter silver nitrate. So right now we're doing an equation where we have magnesium chloride. If you look in your solubility table, you'll see that's aqueous. It's a solution. And it's going to be reacting with silver nitrate solution, which is AgNO3, AQ. And you need to write out your double displacement. You need to do that. So you actually need to show the double displacement happening. So the magnesium will go with the nitrate, and silver will go with the chloride. So we have AgCl plus magnesium nitrate, MgNO3, 2. What do we know about the magnesium nitrate for sure? If it's a nitrate. Yeah, we know it's aqueous. Now, if you look at your solubility table, you will see that the silver chloride is a precipitate. So there's a precipitate there, and we probably know it's a precipitate because we told you there's a reaction here. And to have that reaction, you need the precipitate to be there. So that's going to be a precipitate there. And we're going to balance this. So I'll put a 2 here, a 2 here, a 1 there, and a 1 there. And I'm going to write out all the information that I have. So I have 60 mils of silver nitrate. So volume is 60 milliliters or 0.06 liters. And my concentration is 0.30 moles per liter. Now, they're asking me for the mass, which is moles times molar mass. So I'm just going to write out the molar mass over here. So for magnesium chloride, it's 35.45 times 2, plus the magnesium, which is 24.31. Whoops. And I get 95.21 grams per mole. Okay, so now, in a situation like this, this is no longer just a dissolving problem. This is a reaction problem. Okay, so we're going back to you can only do mole ratios. You cannot do concentration ratios because there's different volumes here. Okay, so you can't do concentration ratios to try to figure it out. You need your mole ratios. Okay? So, right. So we can use our mole ratio to figure out the moles exactly of the magnesium chloride. And then from there we can find our mass. So what we're saying is, remember our formula here is C is equal to N over V. But you can find the moles of silver nitrate by doing N is equal to C times V. If you rearrange this, you get N is equal to C times V. That gives you your moles. So you can go ahead and find your moles of silver nitrate. So let's just make this, step 1 was writing the equation. Step 2 is finding moles of whatever you have there. So we're going to have 0.30 moles per liter multiplied by 0.06 liters. Cross out the liters there. So we have 0.06 times 0.3, and we get approximately 0.018 moles of silver nitrate. Now that we have the moles of silver nitrate, what can we do to find the moles of magnesium chloride? That's right, do a ratio. Exactly. So we have a ratio, a 2 silver nitrate to 1 magnesium chloride ratio. So let's go ahead and do that. We have 0.018 moles of silver nitrate multiply it by 1 mole of MgCl2 over 2 moles of silver nitrate. Cross out the moles of silver nitrate, and you get, so divide it by 2, 0.009 moles of MgCl2. So we're almost done. We have one more step to do to really finish this problem. What is that step? Right, we're looking for the mass now. So mass is going to be equal to our moles times our molar mass, which is going to be our 0.009 moles, multiplied by the molar mass we calculated there, 21 grams per mole. We're going to cross out the mole and mole there. So times 95.21. And we get about 0.85689 grams, or approximately 1 sig fig there, right? So about 0.9 grams. The reason I rounded up, even though there was a 5 here and usually we go to even, is because it wasn't exactly 5. It was 5 and then beyond 5 as well. If it was 0.85, then I could have rounded down to 0.8 because it's exactly at the midline. But here, it's not. It's above the midline. It's 0.85 and higher. So that's why I rounded up to 0.9 grams there of MgCl2. You'd have a therefore statement, of course, but this is your final answer over here. So just to summarize, we were doing a reaction, double displacement with a precipitate forming. We wrote out our equation for that and made sure it was balanced. We were given information about the silver nitrate solution, volume and concentration. We wanted to figure out what mass of magnesium chloride would react with that type of solution there. Now the thing is, you have to use a mole ratio when you're doing these type of problems because the volume is not the same, so you can't do concentration ratios here. You have to do mole ratio. So using our formula, we rearrange it to find moles is equal to C times V. We found the number of moles of silver nitrate. We then did our mole ratio, 2 to 1, and use that mole ratio to find the moles of magnesium chloride. The whole point of finding the moles of magnesium chloride is because we want to find the mass of magnesium chloride. And for that, we need its moles and its molar mass, which we found using our periodic table. So we use the formula mass is equal to moles times molar mass, multiplied our molar mass there, got our final mass in grams, and then did it according to the proper number of sig figs. And that there would be how we do a problem like this. That's a stoichiometry problem going from concentration to mass. You could have gone to other stuff. I could have asked you to go from concentration to moles, concentration to particles. So for example, you would have multiplied the moles by Avogadro's number instead. So it's just applying the correct formula based on what's being asked. Here we just had to use our concentration formula to convert to moles. So in the next part of the lesson, when we come back from break, we're going to do one more example where we go from concentration to volume in a stoichiometry problem. And then we'll do a problem where we have a limiting reactant. So let me just end the recording.